Hello and good morning and welcome to our lecture on scientific notation. So why do we use scientific notation? I mean, here's a number in scientific notation. And why ever write this? What was wrong with the way we normally write this? I mean, if I were to write this, that would be 32 million. So, I mean, do I really need to learn this stuff here if I know how to do this? And in science, you sure do, because sometimes we deal with really large and really small quantities and it gets too inconvenient. Here, it's still kind of easy to see what it is, but if I were to write down something like, and you'd be like, what the heck is even that heavy? That's a 6 here. The Earth. That's the mass of the Earth. Now, if I asked you to write that down, it's tedious because it's a lot of zeros. And if I ask you, well, how much is it? And you basically have to count those zeros. And if you said, hey, I can always put my separators, and I know this is thousands and millions and billions and trillion and quadrillion and quintillion and hexillion and septillion. Oh, 6 septillion. That took time. And if I were to have several numbers like this, it would get really tedious. In scientific notation, we would simply write this as 6 times 10 to the 24 kg. A lot more elegant. And all it tells you, looking at this number, how big it really is. And if I gave you the mass of something else, let's say 7.4 times 10 to the 22, that happens to be the mass of the moon. And that's the mass of Earth. We see that we could easily look at this and say it's about, 10 to the 2 times larger, so it's about 100 times more massive, and it's just much easier to see than if I were to write this out as a whole bunch of zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. There you go. And if I had to compare these two, it'd be like counting the zeros here, counting the zeros there. So you can understand why it's really important to use scientific notation. Now, this also works with the very small. So let's say that I was looking at the mass of an electron. That's 9.1 times 10 to the negative 31 kg. I don't even want to write this in as 0.000, a whole bunch of zeros, 91 kg. I mean, it's painful. So, hence scientific notation. It allows you to even look and see, hey, if I were to compare the mass of an electron to the mass of the Earth, or approximately how many electrons would make the same mass as the Earth, you'd be looking at these two numbers and 24, and then that's a negative 31. So if you look at your number line, you're at plus 24, 0 is somewhere here, and then negative 31. So this here is basically 24 plus 31, and that gives you an order of a magnitude of 55. So it's 10 to the 55 times as massive as the electron. So I hope that helps and helps you understand why we even use scientific notation.